With the COVID-19 pandemic going on, you might have heard about new variants of the virus showing up, such as the UK variant and the South African variant. But how do viruses mutate, and what are the potential consequences of their mutations? Find the answer to these questions in this episode of SciShot. Before we talk about mutations, let's discuss how viruses work. You can think of a virus as a piece of genetic code surrounded by a coat made of proteins. The goal of a virus is to multiply and replicate itself. The genetic code that is inside a virus is the blueprint for all the structures that the virus is made of. It is the recipe that contains the instructions for making a virus. Now imagine you want to cook something based on a recipe you found on the internet. Well, the first thing you would do is to copy that recipe using a printer. Then you would need the right equipment and resources to make what is written on the recipe. Now similarly, a virus needs two things to replicate itself. It needs a printer to copy its genetic code, and it needs the resources and machinery needed to read that genetic code and build new viruses. And well, it has neither of them. So what does it do? Well, it attacks our cells and it steals our equipment. Viruses hijack our cells and turn them into their own virus building factory. Now let's talk about mutations. Mutations are considered as changes in the genetic code of the virus. During the replication of the virus inside the cell, mutations can happen in many ways. But in this episode, we are only going to focus on one of the most fundamental ways. It is known as mutation through base substitution. My friend Parsa will now explain this to us.
Thank you, Priya. Base substitution mutations can happen when the genetic code is being copied by the printers. When the printers are making copies of the virus's genetic code, they can make a mistake during the process and change some of the codes. Going back to our cooking recipe analogy, imagine that the part of the recipe says add 5 eggs. Now the printer is going to copy this code over and over, but after a while a mistake can happen during that process. In this case, the mutated recipe says to add 7 eggs instead of 5. Now when you cook the food with 7 eggs instead of 5, you might end up with food that tastes better, worse, or not that different overall. In a similar way, when the genetic code of a virus is changed, depending on where that mutation has occurred and how much it has changed, we can get a new virus variant that is either more harmful, less harmful, or not that different from the original virus. Our immune system uses certain structures on viruses called an antigen. An antigen is like a fingerprint or ID card that our immune system uses to identify a virus and then kill it. We use vaccines to help our immune system recognize those antigens or fingerprints faster. Now, if the mutation occurs at a location of the virus's genetic code that significantly changes that fingerprint, then unfortunately, the vaccine to that original virus may not be effective anymore against the new mutated variants. Multiple new variants of SARS-CoV-2 virus have shown up during the pandemic at multiple places around the world, some of which may be resistant against the vaccine or more contagious, and some of them may be no different than the original virus. There is still a lot to be learned about these variants, but as the public, the best thing we can do is to continue our efforts in preventing more transmission, wear masks, and get vaccinated as soon as possible if you're medically able to. Thank you, and stay tuned for another episode of SciShot.